So audio, okay, everyone. Somebody in the audience say, yep, can hear you in the back of the room, that sort of thing. I'm one of the Oracle ACE folks, 25 years of Oracle. That's what happens to you. I'm a bit of a dinosaur and I'd like to ride around Europe on a motorcycle. Customer list, obligatory list, obligatory picture of me. There we go. See, I was wearing a mask 10 years ago. I slept in that hotel a couple of nights. I mostly drink coffee. This is the point where I ask, can you guys see my mouse on the screen?
Yes.
So here's my coffee. That is my Singapore desk, by the way. I want to talk about partitioning, partly because somebody said, oh, we need more basic information. And I see a lot of basic things going wrong with partitioning. If you think, well, if you're experienced DBA, etc., you probably know most of this. The summary at the end of my presentation will say, think about your design. And throughout my presentation and my demo, I will say something like, keep it simple. So you have to be able to explain it to the developers, to the DevOps people. You might have to explain it to the architect. It has to be simple. If we're lucky, I finish about 10 minutes early, we can have a bit of a discussion. And I expect a lot of criticism as well, and that's fine. So why partitioning? Why this presentation? Partitioning has two reasons, I think. But first you need to realize that partitioning is to split a large table into many small ones. And by having small tables, you can gain all sorts of advantages, like quickly searching through a small amount of data. There are two reasons why you should use partitioning, my opinion, and you may differ in the discussion. The first advantage is by using partitioning, you could avoid redo. You can, if you have a system with a lot of data coming in and out, you will generate redo on the inserts and redo on the deletes. You can avoid half of that redo in some cases, and that's where partitioning really shines. You can also use partitioning to scan less data. If you query a large table and you know approximately where your data is already, but it's too much data for an index, then you can use partitioning and have your queries crafted so that you only scan 1 or 2 partitions. Your queries become a lot faster. That's the second reason. Keep this in mind. If your architect wants to use partitioning because he gets a kickback from Oracle, fine. If your developers want to use partitioning for their resume, fine. But there are only two real technical reasons why you should use partitioning. Avoid redo or scan less data on queries. Here we go. You can do much more with partitions, and I like these features, don't get me wrong. You can compress partitions separately. You can put them on read-only storage. That's a big advantage. You can use partial indexing in the latest versions. You can use ref partitioning. That's a good feature. I'd really like to test that. You can use hybrid partitions. You can put a partition, you can add a partition to a table that is actually an external table. That's a very neat feature. I've never used it. I can see the advantages though. There's a lot of material. All of that is for the advanced PowerPoints for next month or later on. Now, I would normally look at the audience and ask, any questions so far? Anyone leaving the room because bored? There we go. Let's see if I can show this. Suppose you have a table and an index. You've got records in the table and you have no clue where the records in the table are because on insert, Oracle and not you decides where to put that record. So you have an index where the data is in an ordered fashion. You can 1, 2, 3, 4. And if you look for a particular value, you can use the index and that points to the record in the table. This is a conventional table and a conventional global index. Most of you will know this theory, but for developers, it helps to show them this at the start. Now you've got your partition table. Your data is divided over 4 partitions. All the data starting with a 1 is in the first partition. All the data starting with a 4 is in the last partition in this particular case. In practice, you will probably have hundreds or thousands of partitions. Every partition has indexes, local index. So this index part only points to records in the first partition. Every local index is linked to a partition. You get smaller pieces and you have known content. Oracle, you and Oracle and the optimizer know that everything starting with a 3 is in the third partition and is indexed in the local index on the third partition. It is still a single table, so your developers can still query the table in the from clause, use where clauses and what have you. And my big advice is, if you do this, use local indexes. In this particular drawing, you see a local index because every part of, and every partition has its own corresponding index partition. And this would be the primary key in most cases. If you have a partition table, in this case, 4 partitions with a global index, your table is still partitioned, your index is not. So you can have multiple partitions under the table, but the index is a single storage piece, a single segment in VBA words. And your entries, for example, you have a field called active is yes or no, and the no's are in the index, and somewhere at the bottom of the index are all the yes fields. And the yes fields point, if you have a particular entry, the N will point to records all over the table, and the yes fields, the yes entries will point to records all over the table. So this global index is pointing to, is linked to all of the partitions. And that's where the problem comes in a moment. So first question, why did we use partitioning again? First, we want to generate less redo. Let's have a look. Inserts and updates and deletes are work on the data. That causes undo and redo. In Postgres terms, it causes write ahead log, vol data. Vol is exactly or very much equivalent to redo in Oracle. Redo means you get more redo file, bigger redo activity, you get more archive data, and your standby becomes more busy because it has to process all the archives running the standby. You want to delete data? Most people know that the drop or truncate operation is the fastest way to delete data. And with partitioning, this is what you do. By dropping a partition, you don't delete the data bit by bit, you drop it in one go, and that can be a very efficient operation. And then, oops, but then of course, that only works if your partitioning is suitable, if your partitions contain the data that you want to delete. And then you can do a drop partition. You can delete data by dropping or exchanging a partition. You guys want to see how that works? Oh, like this. Alter table, drop partition, partition 1, poof, and it's gone. This is where you look at it. Any questions about this? No, we already know this. But what if that partition table has a global index? Remember, one of those indexes where the index is connected to every partition, and every partition can have entries all over the index. You do the drop partition command, and there it goes. And this would be an exam question. What happens to the index? Because this part of the index is pointing to nothing anymore, and this part of the index is pointing to nothing. And actually, throughout the whole index, there will be entries that are no longer valid, and that makes the index unusable in Oracle terms. It makes it less usable. In future versions, they might, I hope that they'll put workarounds in for this, but at the moment, your index becomes unusable, and that becomes a problem if a query needs that index. Demo time. So we'll make a table T, a partition table PT, same data. We'll delete from the T and see the redo. We'll delete from the PT and we'll see the redo. And then we do this magical thing called drop partition and show that it is much more efficient. There you go. Next difficult part. I need someone from the audience to tell me whether they can read the font on the screen. Somebody raise a hand and say, yes, I can, or totally rubbish. That'd be fine. I'm creating a table. Here you go, the partition table. I'll give it 4 partitions. I'll partition on the ID. So this is a range partition on an integer, on a number field. and probably want an index on that. So I'm giving it the primary key index, and I'll create an identical table T, same fields, same index, same constraint, etc. Insert 40,000 rows in there in the partition table, insert the same rows in the conventional table, and I've got my demo set up. Remind me to give you the GitHub link to the script after the presentation. I have my table with about 40,000 records in it. Of course, I did an estimate statistic, so Oracle thinks it's about 3995. And I've got 4 partitions each with 10,000 records, and the optimizer is about 9,000 each. Yeah. Don't forget to set your terminal to. Okay, so this must be readable for you guys. Here's the demo. We, like I said, will delete from table T, we'll delete from partition table PT, and we'll find out if a drop partition makes a difference. Deleting from T, where ID is lower than, so this is the cheat, I'm deleting exactly the contents of the first partition. And that takes me this amount of redo. If I query that from the stats, it is 23 meg of redo. Let's do that from the partition table. I'm deleting from the partition table, same query, different table. This amount of redo, coming down to about 26 M of redo, still a lot of redo. How about I drop the partition? There we go. Alter table, drop partition. I'm dropping a partition that was not part of the previous delete. So this is a real demo. There is still data in the second partition. I dropped the partition. How much redo did I generate? My statistics tell me I generated 34K of redo. That's almost a factor 1,000 less. This is efficient. So what we just saw was we deleted records from a conventional table, generating a lot of redo and undo. We deleted records from a partition table, still generating a lot of redo. And then we did the magical thing. We dropped a partition with the same amount of data, and that generated extremely little redo. The bonus question is, if I do this with millions of records or gigabytes or terabytes of data, will this number increase? The audience, of course, goes, yeah, probably. And would this number increase? The audience goes, yes, probably. Would this number increase if I did it with gigabyte partitions? Probably not. And this is where partitioning comes in. If you have a redo bottleneck, partitioning can help. The main point was, if you drop a partition, you save on redo, you save on the log writer, you don't have to archive it, and your standby database has less work to do. All of that can save you time. If you work with large volumes of data, this begins to count, and this is why partitioning was introduced somewhere at the end of the 90s in Oracle 8, I think. I could go back to the demo, back to the PowerPoint, or I could show you what happens if I have a global index. Now remember, the global index is connected to all the partitions. The global index would make this delete probably less efficient. Let's have a look. We'll drop a partition with a global index, and we'll drop the same a different partition with the same amount of data on a local index. Let's have a look. I'm creating my global index. So create index, blah, 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 global. And I am ready to drop that partition. Alter table, drop partition. I forgot something. I need to reinitialize the demo. Sorry about that. I've made this mistake time and again. There we go again. We have we'll have a global and a local index, and we'll drop a partition. I'm creating the global index, keyword global, and I'm ready to drop the partition. And there we go. I alter my table, I drop the first partition, and this time it has data in it, and suddenly my index becomes unusable. Now, the guys who read the manual will go, yes, but there is the background job and there is the update index clause, etc. That is very true. But even with those clauses and that background job, the index will still become unusable or very impractical for a short amount of time, longer amount of time if you have more data. And that work, the undo, the redo in the background is still generated. So your gain, even if the problem is hidden by a clever option, the gain is still minimal. In this case, I would need to rebuild that index. I'm doing that manually to show you how much redo effort that would be. The background job can also do it. So I'm altering my index, rebuild it. There we go. That generates about 230K of redo. Now, remember the 230. Now let's drop the global index and we create a local index. Same index, keyword local. What I now get is 4 little pieces of index. 1 piece of index for each partition. Let's have a look what happens if I drop. There you go. I'm dropping my partition. The remaining parts of the table index are still usable. And the amount of redo is about 33K. That's about 10% of what the other operation was. So what we've seen is a global versus local index. If you have a global index on this table, you drop the partition, the index is unusable for a moment, and you generate 200K of redo. If you have a local index, you drop the partition, the index remains usable, and you have a 30K amount of redo, 10%. The first question is, what happens if I make my tables, my partitions a lot bigger? Which of those two numbers will increase? Of course, the answers will be in the chat. Thank you. And the second question is, who knows the background process that could possibly help rebuild that index, and in what version did it come in? I think it got in version 12.2 or version 18. Herman can tell you. Okay. So the main point in this case is, if you want to use that drop partition trick, you should avoid global indexes. And sometimes you might say, oh, I really need a global index. In Poland, I knew there was someone sitting online watching the presentation who said, no, I cannot do without my global index, you know. And I said, yeah, I realized that, but still. So yeah, and I have to say Oracle, sometimes I do the demo, and I do this demo in Oracle, and stop the recording, and I have a similar screen in Postgres, and I can run a very similar demo script with very similar outcome. Oracle is quite good on mitigating these problems, and they improve with every version. You can quote me in saying that Oracle is miles ahead of the competition when it comes to partitioning, but still the global index will hurt you. Back to the PowerPoint and reinitialize my demo for the next one. Never forget that. Okay, so that was the first demo, and we did the global index as well. Any questions, put them in the chat or in the question window. I expect a bit of heat on this, like, oh, your demo is rigged. Yeah, my demo is rigged. This data was ideal for partitioning. The second advantage on partitioning, remember, we saw the redo part. Now about how can I make my queries go faster? There you go. Well, the key is to scan less data, to process less data, less blocks, less I/O on a query. Typical use case will be aggregates over a small or a few number of partitions. The anti-pattern, and what you should try to avoid, is having to loop over all partitions. The CERN database at one point had 1 million partitions, 1 million partitions. If you have to loop over 1 million partitions, loop 1 million steps, that becomes a problem anyway. Let me show you how that's done. On a conventional table, I have my records all through the table, and I want to aggregate something over a range. Let's say I want the range of all the twos, all the records starting with 2. That will probably become a full table scan like this. Somebody will say, oh, could use an index? Yes, but if 25% of your table needs to be counted, you can probably scan the table faster than running through an index for every record all the time. But that can be discussed. We end up with a full table scan, and that's a lot of effort. Now here's the partition table. I'm going to do the same sort of sum, but this time I know where my data is. I know where to go. So I can do that full table scan on just one partition, maybe. And this is where your design comes in. If you know how your queries, how your aggregates and your sum group by day, etc. are going to be, if you know your data and control your SQL, you can design your partitioning to suit that, and then you get the benefit. The downside is if you don't know your data, if you can't control your design or your SQL, your benefits from partitioning will be doubtful. And the anecdote is I've seen probably 10 systems with partitioning, less than 15. 2 of those systems were a definite success, and they were only successful because they had the partitioning in there right from the design. The other 8 were not necessarily failures, but they had enough hardware to hide the inefficiencies. So here, if you scan a partition for an aggregate, you scan one partition, you become a lot more efficient. That's the message here. Want to see the demo? There you go. We'll do the table, we'll do the partition table, we'll do a sum over a range, and let's have a look at that. Yeah. See, I like my demos, even if they are very simple. Yeah. I will aggregate data on table T and on table PT. Now, normally the data I'm looking for is in one or in a few small number of partitions. Let's hit the query. I got to select count and a sum on table T on a range between these numbers. The rigged demo is, of course, the numbers are exactly one partition. I do a table full scan. This table is not partitioned, so I have to get to my whole table. And the full table scan in an explained plan, even a manager knows it's probably not good. All right. And indeed, sometimes the CBO decides to do this by index, but this time I'm lucky. I do the same thing, and this time I ask for the statistics, so still table T, conventional table. I did a full table scan, and I scanned about 6,000 blocks. About 6,000, I scanned the whole table. Let's try the partition table. Oh, yeah, you saw that one. Select the same query from the partition table. Now my plan still says I have a full table access full on the partition, but only partition 2 and 2. So I start and stop at partition number 2. And the next line in the plan actually tells me, yes, you used a single partition for this particular query. And that's a good sign. Let's have a look. Same query, run it again, ask for the statistics. Could anyone predict how much this would be? It is almost exactly a quart of the previous query. That's because I scan a quart of the data. And there's the proof. The number of blocks scanned is a lot less now. And this will have a good impact if you have a table with like 300 partitions, one for each day, and you only need the last 2 days. You only have to scan the last 2 partitions. It becomes really efficient. Also notice, didn't touch any index getting this aggregate. So the main point is, if you can use this trick, this partition elimination, you get much more efficient queries. You don't have to search through your 10 years of history all the time. This is the second part where partition shines. This is where you can use partitioning for. And on large volumes, there's banks and there's a lot of telcos out there that really know, they know that this counts. And their systems are not always that efficient. And they do have global index problems from time to time, but it does make a difference. This is why Oracle asks money for the partitioning option, basically. Go back to the PowerPoint. So that was the demo of scanning a small part of your table, scanning a single partition. There is more to it. If you want to find specific records, that's fine, as long as you're looking for something that has the partition key. If you look for an ID is a number, that'll be good. You can use the local index. If you look for a field that doesn't have a good local index, or that requires a global index, you are in slightly in trouble. you'd have to look for all the active data in a table. And it can be all over the table. So you'd have to either use a global index or use a local index, but then how many partitions are you going to scan? And the anti-pattern will be if you have to loop over the partitions. I can see the questions coming, so let's see if I can explain that. Conventional table, set of records, global index. If the index is on a particular number, primary key, you can look for that number and point to the record and you've got it. That's easy. Conventional table, global index, most developers can still understand this. If you look for the status is active, you have the active fields in an index, so all the n's at the start of the index and all the y's at the end of the index. You go looking, you find where the y's are, and there are about 4 pointers into the table. So you get 1, 2, 3, and you get about 7 jumps, and you've got your data. It's good so far. Now we've got the partition table. First, the index on the primary key, looking for an ID. The cost-based optimizer knows that the ID 1 is in this range. So it goes to that partition, that local index, the index that belongs to the partition where the ones will be found, does 3 jumps, and it gets the data, probably 4 gets to the table. The CBO, the cost-based optimizer oracle, knows where to look for this, and it knows it only has to scan 1 partition. This is where you become really efficient. You can, this is where the problem comes in. I've got my partition table, and I'm looking for something that active is yes. Let's say I take a global index on that. The global index is fairly efficient. I got 3 jumps in the index, and I'm finding my data in about 7 blockheads. So this would be efficient still, but I have a global index. And I told you, global index is not good news if you want to drop a partition. What if I make a local index on the active field? I end up with 4 local indexes, and my search will start in the first partition. I get about 3 jumps through the index and 1 to the table, and I find my record. But I don't know if these are all my yeses. I have to visit the other partitions. And this is where the looping begins. This is where your problem is. And the explain plan will say something like partition all. And that's probably bad news. If this happens for something like a 2-year set of data or 7 years of 300 records, you need to visit 2,500 partitions, your CPU is going to be busy and your end user is going to have to wait for the query a bit. Demo time, partition table. We will select based on the active. Active is yes. There are 4 active records in a set of 40,000. So let's compare global and local index. Reinitialize the demo and run demo 1. Reinitialize the demo. I always forget this. So I've got my partition table with the 40,000 records, and let's run query. I think I just started the wrong date. I think I just started the wrong, no, this is the one. I've got my active, I'm looking where active is yes. I will find 4 records. Remember the drawing with the global index? So in this case, I have a partition table with a global index, and that was created here. I've created a global index on my partition table. So the type of index I don't really want, but the type of index that is good for this particular query. I've done an index range scan on the global index, and I've went into the table based on row ID. A good DBA will now predict, oh, this is probably 3 IOs and then 1 IO for each record. So you'd end up with 7 consistent gets. And that's fairly efficient to pick up this data. What happens if I make a local index? I don't want my global index, so let's replace it by local. And we got local index, statistics on it. And let's do the query. Same query, select from partition table, active is yes. I will get my 4 records, And the explain plan now looks like this. I have an index range scan, which is good, but I'm doing that on all the partitions. See, there is no partition start or end defined. And this, by the way, is the maximum number of partitions you could theoretically have in Oracle. You end up with something that says partition range all. This is fine because I have 4 partitions. If I had like 1,000 partitions, or like CERN, I end up with 1 million partitions in a particular table, this becomes a real problem. Anyone predict how many IO this is? Approximately? Well, 12. I have 3 for each record. So my B level is, I get 2 jumps in every index and 1 jump to the table. And there we go. If you have 1,000 partitions, this would become 4,000 consistent gets. And if you have 1 million partitions in your table, this would become 4 million consistent gets, and it would take considerable time. So the main point is local index can cause you that looping. Local indexes are not suitable for queries that don't contain the partition key. The global index in this case was and is and will be more efficient. This is why Postgres is making a big effort to get global indexes on their partition mechanism. And they had a voting session once in a user group, and everybody voted for the particular form of global index. And I raised my finger and said, can I vote for not having global indexes? And I survived, but people looked at me and like, are you crazy? No, I know that 8 out of 10 systems go wrong because of global indexes. If you really want to ban global indexes, all your SQL must always know, must be able to limit itself to 1 or few partitions. This is your design challenge. All the SQL must have some sort of partition key in their where clause. And that means you have to start this right from the design. This means you cannot back implement, or 99% of cases, you cannot back implement partition on an existing system because it's just not part of the grain, it's not part of the design of the system. If you want to use partition, you have to start mostly at a green field. That is the bad message for people who really want partition, but already have a running system. Questions on this? How's the questions doing, by the way? I'm hoping for time. Okay, so this is what you want to avoid. Avoid global indexes, avoid the extra work on drop and exchange operations. Avoid partition all, so avoid looping. Well, the consequence is that all the queries need a partition key somewhere. And that means upfront design. Did I mention design? I think I did. Now, what am I going to do now? There is a bonus. If you really want to do something based on partitioning on date, here is something that might work. And I think I have time to do that. Because partitions are mostly a date thing. And there is list partitioning, and that's probably a different story, but if you use list partitioning, similar trick applies. You do not want global indexing. You can only afford 1 unique key because there can only be 1 partition key. Hence, the unique key has to be the primary key and has to be the partition key. You cannot have a sequence ID and a date field for partitioning because the sequence ID, if the key has to be unique, becomes a global index. And there's the challenge. Did I say you need to think about this in your design? I think I did. One of the tricks is this. You can take a number, a large 25 digit number or a 64-bit integer. You can use that number to contain both the date and the sequence. You'd end up with something like the year, 2020, the day, 200 and something, but about 300 by now. We are at about the 300th day of the year. Seconds, I think we're about 50,000 seconds into the day. But this would become a large number. And then behind it, I glue a sequence number with leading zeros. And I cycle the sequence at 1 million. And that becomes a 20-digit number. You can use the epoch as the first part of the number. You can take epoch plus a sequence. You can use the date plus a sequence. You end up with 18 digits. You can even use extensive dates like year, month, day. in digits, of course, 24-hour, the minutes, the seconds, and then glue the sequence behind it, you end up with 20 digits. Let me show you how that works. So you could use this as your primary key. What we'll see is we use the date plus a sequence and make that into a primary key field. I need a sequence to get my numbers. So I created the sequence, there we go. I'm doing a select, and just to give you the demo, this would become my ID field, and this is composed of the year. Today is day 275 of the year, and we are at about 47,000 seconds into the day. So I'd end up with this number as the first part, and then this sequence part at the second part of the idea. I have a unique number, and it contains, oh boy, it contains a time dimension. It contains the date and the time. You can use it to pinpoint the date. Now, I can see problems and questions coming. But if I cycle my sequence, my number just goes from 9 to leading 0, and I still have a valid number. And the range is still there. You can even order by this. You know in which order the date came in. Let's see what happens. If we do that, those numbers are about 10 bytes in size. So that's still a lot smaller than using a GUID or anything else. And check even if it is a huge number, Oracle will store that in 10 bytes only. The homework is, of course, how many objections can you think of against this kind of construction for the primary key? I can see the problems coming into the questions, but yeah. And if you would consider a GUID, so a 32-byte string as a primary key, read Frank Pachot's blog. There are pros and cons of that as well. If you use a GUID or something big, you probably use more than 10 bytes for the key to start with. So there we are. This is where, as a good consultant, I will ask you for your watch and tell you the time. If you use partitioning, that will only work from the design, my opinion. If you want to use partition, you could do that to generate less redo. If you need that, don't use global indexes, or not yet, maybe version 2021. If you want to use partitioning for faster queries, you need the partition key in each query, period. So all your queries, your inserts, your deletes, your updates, all need to know in which partition they need to operate. If they don't know that, they will have to look through all the partitions, and they will take a lot of time and effort. So your advantage disappears. Partitioning works. I've seen it work beautifully in 2 cases, but you need to know why, and you need to put that in your design from the very start. What are the useful cases? Well, so this is about, what was it again? Blockchain, oh no, different presentation. Useful cases for partitioning. This is not the cloud. It's not going to solve all your problems. But if you have a time series, you can consider partitioning. If you have fast moving data, data coming in and data being deleted at a high rate, like batch processing stuff, you can consider using partitions. If you have a sharding thing, if you're considering a sharded database with 7 databases all over the world, you might consider list partitioning as well. We need to discuss that separately over coffee, totally different subject, but I'm convinced it'll work. Yeah. You can use partitioning, but you have to know and control your data and your application. And that is the time, and thank you for your watch. There are some interesting items ahead, like Oracle. I told you, Oracle is miles ahead of Postgres or any other system with partitioning. The global indexes that I dislike so much are improving. There are features like partial indexing, ref partitions, and the hybrids that I would love to get my hands on and work with. You know, maybe something for the next presentation somewhere. And maybe we should discuss that, like, what are you interested in regarding partitioning or data storage? Don't believe everything I say. You know, this comes from the internet, so you cannot trust me. But read the manual, start with the concept guides. The guy who wrote most of that, or who redacted most of that, Herman Beer at Oracle, he's the product manager for partitioning. He's a reasonable guy. You know, for an Oracle guy, he's quite okay. This is his Twitter handle. You can also mail him, and he will listen. And we disagree on some items and we agree on most. So if you want to use partitioning, test your case. You know, I can only say I think there are two reasons, the redo and the queries. If you think you have that, by all means also verify that you have the correct requirements and the correct assumptions. When in doubt, simplify. You know, Google for simple Oracle DBA, Twitter handle. This is my favorite quote. The limitation shows the master. It comes from this German poet. You can now ask questions, and you can, well, I'm not in the audience. You cannot shoot me, at least, but over to you guys. That was it.
Thank you, Pete. In fact, we have some questions on the QA. Now I got a new one more. I don't know if
can I see the, here's Q&A. Let's put, I'm reading the Q&A. Range partition, again, partition name. Yes, the partition name. The answer is no. Oracle will generate your partition name unless you explicitly create it yourself. So the first question is, yes, you can determine your partition name, but it means you have to manually or scripted create each partition. So you lose the advantage of automatic partitioning. It's not a big deal. In Oracle 9 and 10, everybody created their own partitions and had no names. And Smeedleiter says, no, you can't. He's correct, but if you do it manual, you still can. Global indexes are bad. What is the feature? Global indexes are bad. Why is the feature there? That's a very good question. The feature is there to sell more hardware. No, kidding. If you want partitioning, and you really need a global index, you can create one. Just realize that you lose the advantage of exchanging, swapping, dropping partitions. And if you have data that never gets deleted, you can partition it and create a global index. It's possible, you know. I don't really criticize the fact that it is there. But if you use global indexes, you lose part of the advantage. Is that answer the question, more or less? Is partitioning the best practice for audit table? The short answer, yes, I think so. Yeah. So audit tables, yes, by all means, if you have those, they are probably good candidates for partitioning. But if you want to look for username or something else in that partition table, if the partitioning is by date and you look for the name of a user, then limit your search to the last month or so. So you only scan 30 partitions and not 1,000. That help a little? Yeah. I think, can someone confirm that they understood my answers? I hate doing this without an audience.
Yes, some of the guys thank for the answers. And also we have one guy in the chat asking you to provide the GitHub.
Yes, thanks. Coming up, chat. I can probably get to chat somehow, right? Can I? I don't see the chat option in my thing.
Maybe it's blinking right now.
Okay. And I just did realize there are more questions in presentation.
Yes, there is more questions coming.
Table statistics. Do you have any suggestions? The answer is yes. Please gather your statistics. The answer to that statistic question is it depends. You'd have to find out what works best in your case. I know in some cases people don't generate statistics. They set statistics for the partitions manually, and that way they control their optimizer better. Okay, what else is there for question? Do you think Oracle has implemented hash partitioning? Yes, hash partitioning, yes. Hash partitioning is useful if you have a lot of parallel query activity. If you have large data sets, mostly read-only data, and you want to query those using multiple CPUs. I'm a bit skeptical on hash partitioning because I haven't seen any serious advantages for that. Okay. I'm not used to scrolling through the questions, by the way. Did I get most of them? And I think my time is up.
Yeah.
GitHub, where can I type my GitHub? There you go. Let me paste in my GitHub thing. This one, that one, that one. Copy, paste. Let's see if that works for you guys. I typed in the answer, disappeared into the void, by the way. Did someone see that?
Just github.com/pdv.
Here's, okay, I got the chat window open. Yeah. And
I think it is that one.
It's in the chat now as well. Have a look.
Check if I shared.
No.
Yes, let me just copy here. No.
This is where we run over time. People start to leave the room and the next speaker comes in and wants to connect his laptop.
No, it says that okay. We have some few time.
But that was it. If you liked the presentation, click the like and subscribe. No. Kidding. No, sorry, I don't do that stuff. No, I really hope to see you guys at some live event again at some point in time. Yeah. And any questions, you can Google for my name. You can contact me on Twitter. You can mail. You probably know where to find me. Yeah,
there is one more question here. Hash plus hash subpartition reduce the index contention. I was sharing the GitHub, so I don't hear if you already answered it.
I see the, I can see the question. Range and hash reduced index contention. Yes, I agree. And index contention was a problem in Oracle 9, 10, and 11, probably 12. Nowadays, with Oracle 18, index contention, you will see, is less of an issue. But if you have serious, fast and large amounts of inserts, by all means, yes, use hash subpartitioning. You can. But realize that effectively you're only on a range partition. Your queries will have to have something that limits the range. So you're limited to one or a few ranges. Ideally, your queries have both the range and the hash key in their where clause. Makes sense. No, I understand that the hash partitioning can exactly reduce index contention. You could have considered reverse indexes. You could have considered additional free space in indexes as well. But no, it's a good solution. No problem. You're welcome.
So I think that's it. We've answered most of the questions. Thank you for the speech. The talk was amazing. Thank you for all of you guys to being here with us today, virtually, but maybe next time we will do physically. See you. Bye-bye.